What if I told you your devices are secretly creating their own IPv6 addresses right now? The EUI64 method is automatically generating unique identifiers from your MAC address, but most network engineers don't understand how it works. In this video, I'll reveal the step-by-step process behind IPv6 auto configuration, show you how to manually calculate EUI64 addresses, and expose a critical security consideration you've probably overlooked. Stick around to master IPv6 addressing like a pro. IPv6 and EUI64 address type. IPv6 addresses also have a subnet mask, but instead of typing something like 3 times 255.0, we use a prefix length. This is pretty much the same as IPv4. The number behind the slash is the number of bits we'll use for the prefix. In our example, this means that the first 64 bits are the network part, and everything behind it can be used for hosts. This address can be shortened like this. Well then, all this is good and easy, but how does it work? If we at this address, with a /57, first of all, we need to determine which party our 57th bit is in. Starting from the left and counting, the red part contains bits from 49 to 64. Now to find out where exactly, you have to convert hexadecimal 121 to binary. Our 57th bit marks the separation between the network part and the host part. As with IPv4, all the bits to the right of the separation must be set to a 0. And then recalculate in hexadecimal. We have more left, which replace this part on our IPv6 address and pass the rest of the right-hand bits to 0 to find our network address. This network address being a bit long, we can shorten it like this. As you may have noticed, in IPv6, you have to get your hands a little dirtier in the binary. It will take us some time to get used to IPv6 addressing and finding prefixes, but the more we do it, the easier it will become. To summarize, an IPv4 address is 32 bits and has subnet masks ranging from 0 to 32. For IPv6, we are on 128 bits, and the subnet masks range from 0 to 128. As for IPv4, there is a part for the network address that is nicknamed the prefix, and a part for the hosts, which is called the host party. And here are some examples of IPv6 address with different mask. An IPv6 address supports 3 types of addresses: unicast, multicast, and anycast. There is no longer any notion of broadcasting because it has been replaced by a specific multicast. On the multicast side, we have assigned multicasts that all start with FF0, and the other multicasts are used in neighborhood discovery. In unicast, we have unspecified routes. We have the default route, the loopback address, the local address, which is the mandatory and essential address for the proper functioning of the protocol, the global unicast, which corresponds to the public address, and the unique local address, which is the private address, generate randomly. That's what we're going to see right away. EUI64, Extended Unique Identifier. An IPv6 address assigned to an interface consists of a 64-bit prefix and a 64-bit interface identifier as well. This identifier can be created in different ways. Either statically, it is manually assigned an address. Either by auto-configuration, using the default EUI64 method, which is based on the MAC address of the network card. Or dynamically, using the DHCP protocol version 6 for IPv6. We'll see how an IPv6 interface address is automatically generated with the EUI64 method. For example, we're going to take a PC and we're going to calculate its EUI64 address based on its MAC address. In IPv6, any device has two addresses, a local address for the LAN portion and a global address to surf the net. To start, we're going to cut our MAC address in two. Then we're going to add FF@FE in the middle of our MAC address. As a reminder, in green is the yes, which corresponds to the unique identifier of the network adapter vendor. And in blue, we have the NIC, which corresponds to the address of the network card. To continue our conversion, we'll take the part of the address that contains the 7th bit of our interface ID. We're going to convert it to binary to target this 7th bit, and we're going to reverse it. If it's 0, we change it to 1, and if it's 1, we change it to 0. Then we go back to hexadecimal, which gives us the part of our interface ID generated by the EUI64 method. In terms of configuration, let's say that our PC is connected to a router. Enabling IPv6 on the router interface with the IPv6 enable command will automatically generate our local IPv6 address with EUI64. And next to our global address, still on the interface, we will simply indicate the network to which it should belong with the command IPv6 address, followed by the EUI64 method to let it choose the address according to the MAC address of the PC interface. And we'll have our global address. And the last important point to see is that when you configure IPv6 on a router, by default, the router does not transmit any IPv6 packets and therefore do not create a routing table either. To activate it, you need to run the command IPv6 unicast routing in global configuration mode.